Now, a little more about ions and radicals. Children, I want to tell you that you people often get confused between the term representation, symbol and formula when it comes about radical. I want to tell you that whether the term is representation of a radical or it is symbol of a radical or it is formula of the radical, it goes for the same. For example, if you are asked representation of ammonium radical, it is NH4 1+. If you are asked symbol of the ammonium radical, then also it is the same, NH4 1+. And formula of ammonium radical is also same, NH4 1+. So you need not to get confused between the term representation and symbol. To understand it better, let's see this example. Here we often ask in this way in the exam. You were asked in class 7th as well the question like this, that give the symbol and valency for the following radicals. And you people do the common mistake which is given in this example. See, name of the radical sulfate, but so many of you in the symbol column write SO4 and in the valency column -2, and both are absolutely wrong. What you should have written was that the symbol should be SO4 -2 and the valency only 2, not minus. Valency will be only 2, not -2. -2 is charge. Valency is a number. It cannot have a sign like plus or minus. So valency will be 2 only, not -2. Similarly, suppose name of the radical is potassium. You people write in the column of the symbol K, which is absolutely wrong. You should have written K plus or K1+. And then valency not +1 but only 1. As I said, valency has no sign. Look at one more example. If it is magnesium radical, it should be like this. Symbol, this is correct and this one was wrong. Symbol is Mg2+, valency 2. Similarly, if it is phosphate radical, symbol PO4 3-, valency 3. So I hope you understood and you are not going to repeat the same mistake. To explain one more thing, let's come to this table. Here is given name of the element, then symbol. This to explain that what is the difference between symbol of element and symbol of radical. See, name of the element potassium, symbol K, valency 1. When the same potassium is the radical, then how do we write? Name of the radical potassium, symbol K, no. Now symbol will be K1+. It cannot be same both the time, K1+. Valency 1 is okay. It means whether it's the valency of element or in the form of its radical, valency is same, number only, no charge. But symbol of element is K and symbol of radical is K1+. Similarly for chlorine. Chlorine is an element, so its symbol of its atom will be Cl, because symbol is of atom for element, symbol is of radical for radicals. So chlorine, Cl, valency 1, but chlorine in the form of radical is not named as chlorine, it becomes chloride. Symbol not Cl, chloride symbol is Cl-1, valency 1. I hope you understood that what is the difference between symbol of element and symbol of radical. Symbol of element is only atom without any charge, because atoms are not having charge. Symbol of radical is along with charge, because radicals are charged. They are not chargeless. Let's move further and see. Cation and anion are the terms used for positively charged radicals and negatively charged radicals, you already know. In the list of radicals, you have to add 2 more positive radicals for learning in your book. One is Hg1+ mercurous, other is Hg2+ mercuric. Why I am asking you to add? Because these are part of so many formula framing, name of the compound and many things, and it is by mistake missing from the book. In the same way, one in the list of anions or acidic radicals, cations are written as basic radical in your book. So it is the same, you know, already we are taught, you are made it clear. And anions means acidic radicals. So Sulfide is very important, acidic radical or anion. You have to add to the list S-2 sulfide. One more I want you to add is O2-2, which is peroxide. Children, oxide is O-2, but peroxide is O2-2. I hope you understood the difference. Let's come to one method of learning polyatomic radicals with similar name. There is a way to understand them for not getting confused, and that is, for example, I am taking example of phosphate, phosphide, phosphide, sulfate, sulfide, sulfide, nitrate, nitrite, nitrite. Out of these 6 are in your syllabus. In your book only phosphate is written, phosphide and phosphide is not written. So if you don't learn, it's okay, but I want you to understand. It's easy. That's why I have given example of phosphate, phosphide and phosphide as well. Now if you learn formula of the first one, that is of ATE suffix, then for ITE and IDE suffix one you can make on your own. How? If you have learned formula of the phosphate to be PO4 3-, then when it comes to ITE phosphide, then it remains same except number of oxygen atom reduced by 1. It means from PO4 it will become PO3 and rest remains same. PO3 -3, just like PO4 3-, this one also PO3 3-. 3- or -3 is same. And what about phosphide? When it reaches to IDE, then oxygen atom are not just reduced, but they get vanished. It means no more oxygen when it comes to IDE. It means the prefix is same. Then if suffix changes from ATE to ITE, then 1 oxygen is reduced, and from ITE when it comes to IDE, then oxygen get vanished. So it becomes only P, and charge still remains same, -3. Now let's come to sulfate. Is the same. If you have learned formula for or representation for sulfate to be SO4 2-, then for sulfide you need not to learn, because sulfide in the same way is same except 1 oxygen reduced, that is from O4 it becomes O3. Rest will remain same. And when come to sulfide, then in the same way oxygen get vanished and rest remains same. So it is S-2. Are you getting how interesting it is to learn like this? And in this way you will not get confused. You learn just first one, sulfate or nitrate or phosphate, and other two you frame on your own by this method. Let's have a look at nitrate. Nitrate, if you have learned that nitrate is NO3 -1, then in the same way for nitrate you need not to learn. You just reduce 1 oxygen. So it will become NO2 -1. It's interesting, no? And for nitrite, as I said, oxygen get vanished. Yet nitrite is in one way is exception to other two, because here valency changes. In case of sulfate, sulfide, sulfide, valency remains same 2. In phosphate, phosphide, phosphide, valency remains same, that is 3. But in case of nitrite, nitrate and nitrite have same valency 1, but in case of nitrite it becomes -3. Children, in the next chapter, in the next period, we'll discuss how to frame formula of the compounds. I hope you understand. Molecular formula of a compound means representation, symbolic representation of one molecule of compound. Like NaCl is molecular formula of sodium chloride, SO2 is molecular formula of sulfur dioxide. And what does the molecular formula of a compound represent? Just like symbol of elements, symbol represents that element as well as one atom of that element. Here molecular formula represents that compound as well as one molecule of the compound. It also shows number of atoms of each element present in one molecule. For example, molecular formula of sodium chloride NaCl, it represents sodium chloride compound. It represents one molecule of sodium chloride. It also represents that one atom of sodium and 1 atom of chlorine combine to form sodium chloride. In the same way, SO2 represents sulfur dioxide. SO2 represents 1 molecule of sulfur dioxide. SO2 also represents that 1 atom of sulfur and 2 atoms of oxygen combine to form sulfur dioxide. Children, please revise and learn everything well and come prepared in the next period.